So yesterday I introduced the beginnings of lesson 4.7, just a smidge, right? Not a whole lot. But the big thing, sine inverse function. I know what I forgot to write on here when I was rewriting this. What's another way to write sine inverse? What was that word?
Arc sine.
Yeah, arc sine x. So, a little piece of information there. But remember the idea of sine inverse? It takes our input and our output and it switches them, right? So we take the input and the output and we switch them. Now we're asking, instead of inputting the angle and getting an answer, our angle is our output. Okay, so we did the first one where it was sine inverse of 1/2. So it was at what angle does sine equal 1/2? We came up with pi over 6. So let's look at B. Now, before we jump into B, check and make sure, is this a valid domain value here? In other words, because this will be important at times, there's my domain. Is that a valid possible domain value? What are valid domain values?
Between negative. Oh yes.
Between -1 and 1. And exactly, grab the calculator if you need to. But square root of 3 is like 1.7. You divide that in half. Is that going to take me less than 1?
Yeah.
Yeah, it's going to take me less than 1. It's in the negatives, doesn't, So that is a valid domain value. You want to check that. Okay? Now, and this is where I'm not willing to fill in the chart today because I have more quizzes to give, obviously. So you're just going to have to be flipping back and forth in your notes, unless you can just off the top of your head remember it. So now I'm going to ask myself, at what angle does sine equal negative square root of 3 over 2? Now, I will say, ignore the negative for a moment. And just think about your chart, right? Think about your chart. At what angle does sine equal square root of 3 over 2? We'll talk about the negative issue in a moment.
60 degrees.
Yes? 60 degrees. Which, what am I actually going to write up here? Well, and actually I shouldn't even write it yet, but I will for the moment. Okay, now, so, and I'm going to go to the back side of our page for a moment. So what that's saying is, when does okay, sorry, get my values right. When does sine equal square root of 3 over 2? And in quadrant 1, and on my basic 3 reference angles, it's at pi over 3, yes? Now, what do we know about quadrant 1, though? Everything is positive. So, my choices are quadrant 1 or quadrant 4. So, what is the equivalent angle to pi over 3, but down in quadrant 4? Negative pi over 3, yes? Now, that negative pi over 3 technically has another name of 5 pi over 3. Yes? However, here's the deal. If you put 5 pi over 3, I can't give you full credit. Because with sine inverse, my possible answers are negative pi over 2 to positive pi over 2. Okay, so when we give answers here, you have to use this version of the answer, which you guys were already kind of doing, weren't you? Because really for sine, if they ask for sine inverse, if they ask you about positive, you're going to give the positive answer up here. If they ask you about a negative, it's going to be half down here in quadrant 4, which sine is negative, and you can just go down here, and it's the same distance up that it is down. So, all of that to say, sine inverse of negative square root of 3 over 2 equals negative pi over 3. And of course, is that an acceptable range value? Is that between negative pi over 2 and positive pi over 2? Which it is, right? So it's the idea that pi over 3 was up here. We need the negative version. Okay? And keep in mind, quadrants 2 and 3 weren't an option, were they? Okay? Which is why we don't have to decide which negative sign quadrant, because you only have one option here. Okay, questions there? Can't get that drawn in. Okay. C. Sine inverse of pi over 2. So this question is asking me, at what angle does sine equal pi over 2?
Negative. No.
Now, what's the catch here? Is pi over 2 a number on our chart? No. Pi over 2 is an angle. Well, and even if we put pi over 2 on there, it's not a value on our chart. You guys are thinking of it in terms of 90 degrees an angle, yes? Well, when you go and do sine of 90 degrees, sine of 90 degrees is up, so that's at 1. Okay? But that's not what this is asking. Okay? Pi over 2 here that they're giving us, it's not an angle. It's a number. Okay? Because remember, they're giving us just numbers, and then we have to figure out the angle. So here's what I want to know. What do you know about pi over 2? No. What do you know about pi over 2?
It's the top of the range. It's the range.
Okay, but this isn't a range value here. This is a domain value. So is pi over 2 in my appropriate domain value? What is pi over 2?
1 point something.
1 point something something something? Because pi is 3.14. You divide that in half, we can at least figure out we're going to be at 1.5 something, right? I believe it's 1.57. And what do we know about 1.57? It is bigger than 1. So here's the deal. Is pi over 2 in my domain? No. So what's that mean about this problem? Yeah, we can't do it. It does not exist. Okay? And this is because that silly little pi over 2 is outside of the domain. So part of the reason we're always checking is that value in the domain, because if it's out of the domain, we just can't do this. So I am saying does not exist. So do you see why I keep asking these questions? Is it in our domain? Is it in our domain? I'm going to keep bugging you guys about that, okay? Okay. D when you're ready? Unless you have a question. Now, what do you notice about D?
Is that a 3?
It is a 3. So what do you notice? Okay, it's hard to read. Got it. Besides that,
There's another side. There's so much.
okay, we have multiple pieces here going, right? Well, here's what I see. I see parentheses, yes? Where do you start on a problem like that? Inside. So here's what I'm going to tell you.
That's on your chart.
Okay? Start with sine of pi over 3. And as I say, start with sine over pi over 3. I hear Kylie say that's on my chart. Because here's the deal. Is this a sine inverse on the inside? No. This is just sine. This is what we learned back in lesson 4.3. Look at your chart. What is the sine of pi over 3 according to my chart? Agreed? Square root of 3 over 2? So that sine of pi over 3 gets replaced with square root of 3 over 2. What do I still have here? We still have the sine inverse outside. And so we're being asked, now, what is the sine inverse of square root of 3 over 2? Or I'm going to turn that around into, at what angle does sine equal square root of 3 over 2? 60, which is pi over 3.
Is there like a thing where if it's inside of that, or is that just a coincidence?
It will often. I can't say the word always. So here's the deal, guys. What are sine and sine inverse doing to each other?
Cancel each other.
Yeah, they're canceling each other out. They're undoing each other. Okay, that's what inverses do. Okay, if you have the original function and inverse, they're going to undo each other. And that's what's generally happening. Now, Kylie was saying, will it always be this way? I can't say always, because it all depends on what quadrant things started off with. Okay? Because here, the sine of pi over 3 was just a typical first quadrant piece, right? So we got square root of 3 over 2. I forgot to have you check your domain, but square root of 3 divided by 2, we already talked about that earlier, that's an acceptable domain piece. But if it hadn't, that can make a difference as to whether your answer is exactly the same as it started off. It can be, and it often is, but not always. And I believe I have an example somewhere on here where it's not exactly, okay? So E, sine inverse of sine of 5 pi over 6.
Check the domain.
Okay. Now, when we talk about checking the domain, I keep talking about checking the domain of sine inverse. Well, that means what do we need to find first?
Oh, that's fine.
Yeah, we've got to start on the inside again. And we've got to find sine of 5 pi over 6. So sine of 5 pi over 6. I don't want a calculator answer. Example 2 is calculators. These aren't calculator answers. I want to go to the chart. But is 5 pi over 6 on my chart? No. So if I do a little side thing here, where is 5 pi over 6?
Right below 6 pi over 6.
Right where? I guess it depends what you mean by below.
Oh. In the third quadrant. Or wait. There we go.
Second quadrant.
I was,
Below it numerically, in my opinion, above it on the graph.
Yeah.
But that's why I was like, I'm not sure what you mean by below.
I keep going the negative way for some reason.
Okay. So 5 pi over 6 is here, correct? So we want to know the sine of that angle. Well, what is the reference angle for 5 pi over 6? Pi over 6, yes? That right there is a distance of pi over 6. So that means, do you remember how this works? I want to know the sine of pi over 6 in quadrant 2. What is the sine of pi over 6 in quadrant 2? Sine of pi over 6 is?
Positive.
Well, according to my chart, sine of pi over 6 is 1/2. According to quadrant 2, what do we know about sine here?
Oh, it's positive.
It's positive.
It's positive. So this is a positive 1/2. Agreed? Did we get there? I know, I kept hearing lots of little issues. I'm like, okay, just gotta keep going. We'll get there. So in this case, it is a positive 1/2, correct? Okay. Had this been down in quadrants 3 or 4, so like 7 pi over 6 or 11 pi over 6, then we would be talking negative 1/2. Okay? So now, I'll go back and entertain Kylie's question. Is this an appropriate domain value?
Yes.
Yeah, 1/2 is definitely okay. So now we're doing sine inverse of 1/2.
Pi over 6. So it has to equal to the parentheses.
Okay, at what angle does sine equal 1/2?
Pi over 6.
This is positive 1/2, and it is pi over 6 according to my chart. And here's the deal. That 5 pi over 6, this answers the question of if you have a function and its inverse function, are they always going to cancel each other out and be exactly? No, because pi over 3, that was in quadrant 1. That was doable. 5 pi over 6? 5 pi over 6 is over here, guys. That right there is my clue that my final answer cannot be 5 pi over 6 if I'm doing sine inverse, because that's not in the appropriate range. Okay? Whoops, wrong way. So that hopefully answers the question from earlier. And there's proof, right? Excuse me. We have a little F thrown in there. Okay. Sine inverse of negative 1.
So that is on the domain. It's on the domain.
Yeah, so if you check your domain value, is negative 1 part of my domain? Barely, but it is, right? Excuse me. So, this is sine inverse. At what angle does sine equal negative 1?
Negative 90. Negative pi over 2. Negative pi over 2.
And why are we coming up with negative 90 or negative pi over 2?
Because you go down, because it's negative 1. Then right there's negative pi over 2.
Okay, so you're not finding a negative 1 or even a 1 in the sine column on your chart, are you? Okay, so this is 1s and 0s came up with the exception of tangent. Those for sine and cosine come up on the quadrantals, right? On your axes. So right here, if I use this as my example, where is negative sine of negative 1? Sine of negative 1 is down here at left or right 0, down 1, right? Does that make sense? And I shouldn't really be writing this on my inverse graph, but this is the visual we have. That it's going to be right there. That would normally be our point, yes? So sine of negative 90 or negative pi over 2 equals negative 1. So if we reverse this, when does sine equal negative 1? And that is
Pi over 2.
negative pi over 2. Now, that one worked out. No one said, the first answer I heard was negative 90, negative pi over 2. Would I accept 3 pi over 2?
Where did you get 6 pi over 2?
Okay, so let's review the fact that if we were going positive, what is another name for this angle? If we go positive, it's 270 or 3 pi over 2. Would I accept 3 pi over 2 as an answer?
Yes.
No, I will not here. Okay, and I cannot here because what is our range for sine inverse?
Pi over 2.
Negative pi over 2 to positive pi over 2. Does that make sense? So I have to be, these are your values you're allowed to give. You can't give the positive versions of these down here. Okay, so just kind of beware. Okay, questions there? Okay, example 2. Use a calculator in radian mode to evaluate these inverse sine values. Pretty self-explanatory if you ask me. Why do I need to be in radian mode?
Because we want our answers in radians.
Okay, yeah. And here's the deal. General rule of thumb, anytime you are working with trig functions, unless you know you have a degree you're being given, you need to be in radian mode. Okay? Now, how do I do sine inverse of negative 0.81?
Do I have to do the sine and then make it negative 0.81 and then put the negative 1 on top, or just use the sine negative 1?
Second
Sine.
Okay, we talked about this. I mentioned this yesterday because back when we were trying to do reciprocals, I said you could not use the second sine function. But is this a reciprocal I'm doing?
No.
No, this is an inverse. Because this is an inverse, you're going to do the second function. So I didn't bother to put my calculator on the screen. I don't feel like I need to. Sine inverse of negative 0.81, what are you getting?
Negative 0.9.
3 decimal places?
94.
Yeah. Negative 0.944. Now, does everyone agree?
Yep.
Did you get your calculator to produce the same answer?
Yes.
Okay. Okay, B. Type it as you see it. Type it as you see it. See what kind of answer you can get. And by the way, don't ever just type 3.14 for pi. Always use the pi button.
Negative.
What'd you say?
Negative 1.5.
Yep. Negative 1.539 is what you should be getting. Good.
I'm guessing that's probably not as easy as your homework's gonna be.
Your homework's going to be more of the other stuff. Your homework's not going to have a bunch of the calculator stuff. I mean,
So close.
but and this is a big thing going forward because I'm still going to catch you guys mixing them up. When we do a reciprocal, you have to use the regular function and you manually raise it to the power of -1. When you do an inverse, you're using the second function button. Okay? And bad news, we didn't get through everything. Good news, that's a good stopping point. So, tomorrow we'll talk about cosine inverse and tangent inverse, which are similar. They have their own little tricks along the way, of course. Okay? And I would say, I'd like to think you should have some work time tomorrow.